Welcome to the lecture series of Fourier transform. In this video, I will discuss about the Fourier transform of a given signal xt. If a signal is given by as follows, this is the xt. So, if you need to transform the Fourier transform, you need to perform some tricks. I should say, by this way, your calculation would be very easier. So, if you have a close look on that signal, you will get that this is a kind of this signal can be composed of several rectangular signal like that and this way. So after summing of all, this signal can be determined. So as we know that the Fourier transform of a rectangular signal is sinc function like that, so it would be very easier to have a final Fourier transform. So actually, as I have said, that this function can be transformed the summation of that two signal. Like this portion is a rectangular function x1t, another signal x2t is given by the this signal starting from -2t. So we can sum these two signal to compose this signal actually. And what would be our advantage in that way, that we know actually the Fourier transform of that signal and this signal. So this signal we can present this signal by this function to rectangle tt divided by 8, because the magnitude of this portion -4 to 4 is 8, so t divided by t, as we have discussed in earlier. So in this fashion, this magnitude is 2, so here 2 has been written here. 2 is also written here for the similar fashion as we have seen here. So here the distance from -2 to t is 4, so t divided by 4. So this is the two presentation which is composed of the signal. And we know, as we know, that the transformation of a rectangular signal is nothing but the sinc function multiplied by tau and omega tau divided by 2. So here in this case, for this signal, the value of tau is 8. So our Fourier transformation of x1t is given by the 8 sinc omega t divided by 2, and finally we can write 8 sinc for omega. And in similar fashion, for the signal x2t, our Fourier transform will be 4 sinc to omega. So our final as the Fourier linearity property of Fourier transform suggested that that you can transform the whole signal by transforming separately, as it is composed of the several signals. So we have the Fourier transformation of x1t as like that. Fourier transform of x1t is x1 omega, x1 for x2t is x2 omega, and after summing up all, we can get the overall Fourier transformation. So another signal, if we are given like xt, as we can see here, in the similar fashion we can transform the Fourier transformation of given signal xt. Here in that portion can be written as like 2s by t minus t by 2 minus 3. Between that point to that in time axis is 4. This is so 4. So 4 is written here. However, the center is at the origin, but at that case our center for that part, our center would be at this point. So what would be the value of t at that point? The value might be the center between the -4 and -2. The center of between -4 and -2 is nothing but -3. So -3 is written here, as like t divided by 4 -0 is written here. So -0 is nothing but t divided by 4, and t divided by 8 -0 is like as t divided by 8. But however, but in that case, our center for this portion, our center might have at the point here, so at the middle point. So middle point between the -4 and -2 is -3, so t by 2 -3 would be written here. So so why we should write 2? Because as in case in that case 4 is written for the distance between that two point was 4, so 4 was written there. So in that case the distance between 2 point is 2, so 2 should be written here. So this part actually represent that one, and this part actually represent that one. So in that case the center will present between 2 and 4, so 3 would be here, and the distance between two point is 2, so 2 by 2, and the magnitude is 2. So these two part actually represent the xt, and our ultimate goal is to transform the Fourier transform xt into x omega. So, and we know actually the Fourier transform of a rectangle function is nothing but tau into sin omega t tau divided by 2, where tau is represented and we can actually determine from the signal. So here 2 is written here. The ultimate Fourier transform of that portion is 2 sin omega 2 divided by 2. Why 2 is divided by 2? Actually we need to determine the x omega. So here if we actually know the Fourier transform of rectangle function is tau sin omega tau divided by 2. So first of all we need to determine the value of tau. Actually we know the tau actually the distance between two point actually. So for this case the distance between -4 and -2 is 2, so the value of tau in this case is 2, and in that case the distance between 2 point is 2, so the value of that case is also 2. So the Fourier transform of that portion would be like that. So tau would be equal to 2, so the value of tau is equal to 2 sin omega 2 divided by 2, and this would be the if we want to transform a rectangle function of t divided by 2, no time shifting, if no time shifting is present there. However, in our cases time shifting is presented here, so we should use the Fourier transform properties, time shifting property. Actually if we have the Fourier transform of xt is given by x omega, then if we want to transform x of t minus t naught as the time shift at t naught, then we just need to multiply x omega by e to the power minus j omega t naught, where t naught is the point where the signal has been transformed or shifted. So in that case the Fourier transform of rectangle t by 2 is 2 sin omega 2 by t. However, it has been shifted in t is equal to 3, so e to the power j omega 3 would be, or e to the power j 3 omega multiplied here. So in the similar fashion, e to the power minus 3 omega t 3 omega minus 3 would be minus 3 omega would be multiplied with that part, because it has been shifted in 3 and it has been shifted in minus 3. As you have a close look on it in accordance with these two properties, it would be very helpful and very easier for you. ultimately I will request again that you should try several times, and you need to understand the properties and how we should use these properties for our calculation.